My dear students of class 11, welcome to our today's class. I am MD Asghar Khan, Senior Lecturer, Department of Mathematics. My dear student, I hope that all of you are well. By the grace of Almighty Allah, I am also fine. This is our 8th lecture on these topics, I mean matrix and determinant of your higher mathematics. My dear student, I also hope that you are studying well at home during this situation. Already you have completed lecture 1 to 7. If you have completed properly lecture 1 to 7, then this lecture and upcoming lecture will be easy for you. And this type of lecture, my suggestion is you have to watch this video thoroughly from beginning to end, and then you have to make your lesson by this video, then you will have no problem with mathematics. Our today's topic is solution of system of linear equation by the determinant, and this type of process was introduced by the Swedish mathematician Gabriel Cramer, and that's why this method is called a Cramer's rules. Okay, my dear student, let's go to our today's class. Okay, our today's topic, solution of system of linear equation with the help of determinant, and this solution method is called a Cramer's rule. Okay, at first, before solution, we have to know what is linear equation, and the equation is in the form of ax plus by plus c is equal to c. This is called a linear equation, where x and y are variable and a, b, c are constant. And multiple of linear equation is called a system of linear equation. Okay, this is the two variable equation. So system of linear equation with two variable, as example, system of linear equation with two variables. Okay, example is just with two variable. Example is a1x plus b1y is equal to c1, and a2x plus b2y is equal to c2. Two equation for two variable, and this equation is called a system of linear equation. Here two equation involved with this system, and both are linear equation with two variable, and this is called system of linear equation with two variable. Now we want to discuss how we can solve this equation, system of linear equation by the determinant, and this rules is called a Cramer's rules. Okay, according to the Cramer's rule, how we can solve this equation, this now we want to discuss it. Okay, at first, two equation is a1x plus b1y is equal to c1, and a2x plus b2y is equal to c2. This is the system of equation of two variable. Now we want to discuss about the solution of this equation, that means the value of x and y. And in previous class already we have completed this type of solution by substitution method, elimination method, and cross multiplication method. But in this class you will know how you can solve this equation by determinant, and this law is called a Cramer's rule. Okay, now we want to create a determinant with the coefficient of x and y. With the coefficient of x and y, this determinant is denoted by D, and this determinant is the coefficient of x and y, formed by the coefficient of x and y. The coefficient of x is a1, a2 and b1, b2. This determinant is denoted by D, and this determinant is created by the coefficient of x and y. Now another determinant we want to create it. This determinant is denoted by dx. D subscript x is equal to the coefficient of x is replaced by the constant term, and it will be, then this determinant will be c1, c2 and b1, b2, and this determinant is denoted by dx, which is created from this equation. From this determinant, the coefficient of x is replaced by the constant term, so dx is equal to this. Another determinant is denoted by dy, which is created from this determinant. The coefficient of y is replaced by the constant term. So a1, a2, coefficient of y is replaced by constant term c1, c2. Okay, already we have got the three determinant d, dx and dy, and now how we can solve this equation by this determinant. Okay, my dear student, now x is equal to determinant of dx is divided by d, then the result is the value of x, and the determinant y is equal to the determinant of dy is divided by d, then the result is the value of y, and the value of x and y is the solution of this system of linear equation. Okay, this is our method. Now we want to solve this equation by this method. Now question number 21 from exercise 1c. This is the system of linear equation. Now we want to solve this equation by the determinant or by the Cramer's rule. Okay, so our solution is our solution of this equation. At first we want to create a three determinant d, dx and dy. Then we want to find the value of x, y. Okay, at first we want to create a determinant with the coefficient of x and y. So determinant by the coefficient of x, x and y, which is denoted by d, is equal to coefficient of x and y. Here coefficient of x 2 and 1. Here the coefficient of x is 1, the coefficient of y is -1. Okay, so determinant of d is equal to 2, 1 and 3 minus 1. Okay, the value of this is equal to multiply this, we can write minus 2 and minus 3 is equal to minus 5. Okay, this is the value of d. Now dx, okay, dx is a determinant. The coefficient of in d, the coefficient of x is replaced by the constant term, then this is denoted by dx. Okay, so dx is equal to, the coefficient of x is 2 and 1 is denoted by 4, 7, and coefficient of y not changed, 3 minus 1. Okay, multiplication of this way is equal to, at first multiply in this way and then this. Okay, then 4 minus 1 minus 4 and minus 21 is equal to minus 25. Okay, this is dx. Now dy is equal to, in d the coefficient of y is replaced by constant term, so 2, 1, and coefficient of y 3 minus 1 is replaced by 4, 7. Okay, the value of dy is equal to 14 minus multiply in this way, 2 and 7, 14, and then 1 and 4 is equal to 4 is equal to 10. Okay, now we want to find the value of x and y. According to our Cramer's rule, x is equal to, according to our Cramer's rules, x is equal to x is equal to dx divided by d. Okay, here dx is equal to, here dx is equal to minus 25, dx is equal to minus 25, and d is equal to minus 5. Our answer is 5. Okay, and y is equal to dy divided by d. Here dy is equal to 10 and d is equal to minus 5. Then dy is equal to minus 10 and d is equal to, dy is equal to 10 and d is equal to minus 5 is equal to minus 2. Okay, so our required solution of this system of linear equation is, our required solution x comma y is equal to, x is equal to 5 and y is equal to minus 2. Okay, our answer is this. Okay, answer 5 comma minus 2. This is our solution of this system of equation by the determinant which is known as a Cramer's rule. Okay, now solution of system of linear equation with 3 variables. As example, the equation system of linear equation of 3 variable is here. A1x plus b1y plus c1z is equal to d1, and a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. This is the system of linear equation for 3 variable. Now how we can solve this system of linear equation? By the Cramer's rules. At first we want to create a determinant D, which is created by the coefficient of 3 variables. Okay, coefficient of 3 variables. Okay, so D is equal to, denoted by D is equal to coefficient of 3 variables, x, y, z. So coefficient of 3 variables a1, a2, a3, and b1, b2, b3, and c1, c2, c3. This is the determinant D, which is created by the coefficient x, y, z. Now determinant of dx, determinant of dx, which is created by the, which is created from this determinant. The coefficient of x is replaced by constant term. Okay, so d1, d2, d3. Okay, the other two column will not be changed. So b1, b2, b3, c1, c2, c3. Okay, now dy is equal to, okay, the coefficient of b replaced by constant term, and other two term will not be changed. Okay, so a1, a2, and a3. Okay, so change of second column by the constant term. Okay, just d1, d2, d3, and other term will not be changed, which is c1, c2, and c3. Okay, now dz is equal to, dz is equal to the third column changed by the constant term. Okay, other two column will not be changed, a1, a2, a3, b1, b2, b3. Okay, third column is changed by constant term, d1, d2, and d3. d1, d2, d3. Okay, in dx, just first column is changed by the constant term, and dy second column is changed. That means coefficient of b is changed by the constant term, and coefficient of z is changed by the constant term. Okay, now how we can find the value of x, y, z? Now x is equal to dx divided by d, and y is equal to dy divided by d, and z is equal to dz divided by d, where d not is equal to 0. And this is the method for system of linear equation, solution of system of linear equation with 3 variables. Okay, now system of linear equation, the example of system of linear equation with 3 variables, question number 26 of exercise 1c. Okay, at first, for this solution, at first we want to create a determinant of d, which is created by the coefficient of x, y, z. Okay, so our solution, okay, at first the determinant d is equal to which is created by the coefficient x, y, z. X coefficient of this is 1, so 2, 1, 3, and coefficient of y minus 1, 3, minus 1, and z minus 1, 2, minus 5. Okay, now the value of this determinant is equal to, already we have know how we can find this determinant, find the value of this determinant. You can expand by any row or column. Okay, just we want to expand by this row. Okay, at first we want to consider the 2 and ignore the row and column of 2. Then the reduced determinant is 3 to minus 1 minus 5. So expand by this row is equal to 2 into ignore the row and column of 2 is equal to, that reduced determinant is 3 to minus 1 5, 3 to minus 1 minus 5. Okay, then minus the second element is minus 1. Okay, second element is second element of first row is minus 1. Okay, so for minus 1, okay, ignore the row and column of minus 1, then ignore row and column. Okay, then our element is 1, 2, 3 minus 5, 1, 2, 3 minus 5. Okay, now third is minus 1. Okay, our sign is plus and number is minus 1. Okay, now ignore the row and column of minus 1. Okay, ignore the row and column of minus 1, this element, and this is column, and ignore this row. Then our determinant is 1, 3, 3 minus 1. Okay, now the value of this is, okay, 2 into minus 15 and minus 2, and then minus 2 by formula is minus, it will be plus 2, minus and minus plus, and minus 5 then minus 6. Multiply this and minus of multiply this, so minus 6, and minus 1, multiply this minus 1, and minus of multiply this minus 9. Okay, now our value is 2 into minus 13. Now minus 5 minus 6, it will be minus 11, and minus 10, minus 1 multiply with minus 1 is equal to plus 10. Okay, minus 26 minus 11 plus 10 is equal to minus 27, which is not is equal to 0. Okay, so it has a solution because d is not a 0. Okay, my dear students, now dx, which is the coefficient of x is replaced by constant term 6, 1 and 1, other two column will not be changed. That means coefficient y and coefficient of z will not be changed. Minus 1, 3 minus 1 and minus 1, 2 minus 5. So the value of this is equal to expand this determinant by the first row, and then value is equal to minus 81. For 6, ignore row and column, minus 15, minus 2, minus and minus will be plus. So minus 15 plus 2, and for minus 1, the row and column, ignore the row and column, then minus 5 and minus 2. Okay, and for minus 1, ignore the row and column, then minus 1 minus 3. Okay, the calculation of this value is minus 81. And similarly dy dz, where dy, the coefficient of y is replaced by constant term, and the value of dy is this. Okay, by the first row, and dz, the coefficient of z is replaced by constant term 6, 1, 1, and other two coefficient will not be changed, and the value of dz is equal to this. Okay, now from previous one, d is equal to minus 27. Now we want to find the value of x, y, z. Okay, by the Cramer's rules, we have x is equal to dx divided by d, and y is equal to dy divided by d, and z is equal to dz divided by d. Okay, now x is equal to dx minus 81 divided by minus 27, and y is equal to dy is equal to 54 divided by minus 27, and z is equal to dz is equal to minus 54 divided by minus 27. Okay, and here x is equal to divide this is equal to 3, so x is equal to 3, y is equal to divide this is equal to minus 2, and z is equal to divide 2 is equal to this is equal to 2. Okay, our required solution is okay, this is our answer. My dear student, this is our today